Hey, what's up? How are you?
I'm good. How about you? Good. I'm just tired, you know. Same.
So what was your chemistry homework again?
I think it was something about the types of bonding.
Oh, okay. Wait, what bondings do we have to cover?
I had metallic.
Oh, okay. What's metallic?
Metallic is when you have a couple atoms and the electrons just go between the atoms. It's like what Happy's doing right now. He's just going between both of us. He's not like attached to one electron or one atom. So he just moves freely between us, and like that's what would happen in like a metal compound.
That's true, since we don't have much attraction, right?
Mm-hmm.
Oh. But he has attraction to the pig, apparently.
Yes, that he does.
I just remembered what my bonding was.
What was it?
It was ionic.
What's ionic?
Why don't you get me a leash and I'll explain.
Sure, here.
Okay. So, this leash will be the effective nuclear charge between the electron and me. Right now, I have more effective nuclear charge than you. See how I have more control and more attraction than you?
Mm-hmm.
So that's why I have the greater amount of nuclear effective charge. So,
Okay.
even though we're sharing the electron between us two, since my effective nuclear charge is higher, he can't come to you. Even if he wants to go to you, he can't go to you.
Oh, that makes more sense.
Yeah?
So, because you have an extra electron, Happy, what does that do to you?
That makes me more negative, or like an electronically negative charge, or even like basically negatively charged more.
So an anion?
Yep, basically an anion, because I gained an electron. That means that I am more negative than you. So that means I have more an attractive charge than you.
So I would become a cation.
Yep, basically, because you
Okay.
lost an electron.
Okay. That makes more sense.
Yep, there you go. Fine, have it. So hey guys, today we're going to talk about the properties of the two bonds that we talked about, ionic and metallic. And so the first property that we're going to be talking about is that it dissolves in water. And so when it dissolves in water, the negative charge and the positive charge bond is broken because of the polarity.
This is all for ionic, by the way.
Yeah, this is all for ionic. Don't get it mixed up. Then the second property is that it conducts electricity when it dissolves. So when the positive charge and the negative charge is broken, the bond between the two are broken by polarity, the ions are now able to move freely. So when it moves freely, it conducts electricity. That's basically that property. The third property is that it's a brittle solid. So you might be asking, what is a brittle solid? So the closest example that we can think of, it is a wafer. So basically, if you try to bend a wafer, it breaks. You can bend it, or like you can't make it look cool, nothing. When you bend a wafer, it breaks. So that's basically what a brittle solid is. Lastly, it is made of metal and non-metal atoms combined. So basically, the reason that it's made of metals and non-metals is because the metals lose the electron, and the non-metals gain an electron. And what is this called again?
This is ionic bonding.
Ionic bonding, yes, but isn't it a cation or something like that?
Oh yeah. When the metals lose an electron, they become positively charged, and so they become a cation.
Ah, okay. And then the non-metals become anions, right?
Yeah.
Okay, that makes so much more sense. So that's basically all the properties of ionic bonding.
Okay. Now we're going to be talking about metallic bonding. So, where do you see metallic bonding? So, if you ever held a piece of jewelry, so, I don't know, you had a necklace or something, that's an example of metallic bonding. So, metallic bonds don't dissolve in water. And this is because water can't break apart the bonds in a metallic compound. Metallic bonds can also conduct electricity. And this is because, if you think about it, metallic bonds are basically atoms in a fixed structure amid a sea of electrons. So the electrons just like flow around everywhere. And so these electrons can go through wires, go into a light bulb, turn it on, and then come back. So it's like they aren't fixed to anything, so they can move around and they can power things like light bulbs. They're also really bendable. This is because the sea of electrons allows the atoms, which are in a lattice structure, to fold and bend. And that's also why they're ductile. That's also why they're able to be drawn into wires.
That makes sense.
Mm-hmm. And then they're also made entirely of metal atoms. And this is because no other group of elements can form this type of compound. And it's like the lattice structure, and with the sea of electrons, is only made with metal atoms. And that's a wrap. Hallelujah, hallelujah.